200 amp continuous rated primary disconnect switch is suitable for a 500 kVA transformer operating from 2400 volts delta to 480 volts delta with a primary current of 125 amps. The function of the primary disconnect switch is to isolate the transformer from the electrical power source for maintenance tasks or during emergency situations. The continuous current rating of the disconnect switch must be at least equal to or greater than the maximum current that the transformer is expected to draw. In this specific instance, given that the transformer exhibits a primary current of 125 amps, a disconnect switch rated for 200 amps continuously is ample. While upgrading to a 400 amp switch would offer a more substantial safety margin, it is not a mandatory requirement from either a safety perspective or a performance viewpoint. The 200 amp switch possesses the capacity to manage the current drawn by the transformer in conjunction with the other connected loads within the electrical system. Consequently, opting for the 200 amp switch presents an opportunity to reduce expenses without any detrimental effects on safety or operational effectiveness. When selecting a disconnect switch for a transformer, several factors must be considered to ensure safe and reliable operation. Firstly, the continuous current rating of the switch must be sufficient to handle the maximum primary current of the transformer. This rating ensures the switch can carry the load current without overheating or failing. Secondly, the voltage rating of the switch must be equal to or greater than the primary voltage of the transformer. This ensures that the switch can safely interrupt the circuit under fault conditions. Thirdly, the interrupting capacity of the switch must be adequate to handle the maximum fault current available at the transformer primary. This rating is crucial for safely clearing faults and preventing damage to equipment. Fourthly, the switch must be properly installed and maintained to ensure reliable operation. Regular inspections and maintenance can help prevent failures and extend the life of the switch. Fifthly, the switch should be selected based on the specific application and environmental conditions. Factors such as temperature, humidity, and exposure to corrosive substances can affect the performance and lifespan of the switch. The National Electrical Code, or NEC, provides guidelines for selecting and installing disconnect switches for transformers. NEC Section 450.3 specifies the requirements for overcurrent protection of transformers, including the selection of appropriate disconnect switches. NEC Section 450.14 covers the requirements for transformer disconnecting means ensuring that transformers can be safely isolated from the power source. In addition to the NEC, other industry standards and best practices should be followed when selecting and installing disconnect switches. These standards provide guidance on topics such as switchgear design, testing, and maintenance. Proper coordination with qualified electrical engineers and contractors is essential to ensure that the disconnect switch is properly selected and installed. The use of a 200 amp disconnect switch is adequate and will work for this installation. There are several types of disconnect switches available, each with its own advantages and disadvantages. Firstly, fuse disconnect switches incorporate fuses within the switch to provide overcurrent protection. These switches are commonly used in applications where both disconnecting and overcurrent protection are required. Secondly, non-fuse disconnect switches provide only disconnecting means and require separate overcurrent protection devices. These switches are typically used in applications where overcurrent protection is already provided elsewhere in the circuit. Thirdly, load break switches are designed to interrupt current under load conditions. These switches are suitable for applications where the circuit needs to be switched on or off frequently. Fourthly, non-load break switches are not designed to interrupt current under load conditions and should only be operated when the circuit is de-energized. These switches are typically used for maintenance or isolation purposes. Fifthly, manual disconnect switches are operated manually by an operator. These switches are simple and reliable, but require manual intervention to operate. Sixthly, automatic disconnect switches are operated automatically by a control system. These switches are suitable for applications where remote or automated operation is required. The selection of the appropriate type of disconnect switch depends on the specific application requirements. Factors such as current rating, voltage rating, interrupting capacity, and operating characteristics should be considered when making a selection. Proper coordination with qualified electrical engineers and contractors is essential to ensure that the disconnect switch is suitable for the intended application. The installation of a disconnect switch involves several steps to ensure safe and reliable operation. Firstly, the switch should be installed in a readily accessible location. This allows for easy access for maintenance and emergency situations. Secondly, the switch should be mounted securely to a stable surface. This prevents the switch from moving or vibrating during operation. Thirdly, the electrical connections should be made in accordance with the manufacturer's instructions and applicable codes. Proper connections are essential to ensure reliable operation and prevent overheating. Fourthly, the switch should be properly grounded to provide a safe path for fault currents. Grounding is crucial for protecting personnel and equipment from electrical shock. Fifthly, the switch should be tested after installation to verify proper operation. Testing can help identify any potential problems and ensure that the switch is functioning correctly. Regular maintenance of a disconnect switch is essential to ensure reliable operation and extend its lifespan. Firstly, the switch should be inspected regularly for signs of damage or wear. Inspections can help identify potential problems before they lead to failures. Secondly, the electrical connections should be tightened periodically to prevent loose connections and overheating. Loose connections can cause voltage drops and increase the risk of fire. Thirdly, the switch should be cleaned regularly to remove dust and debris. Dust and debris can accumulate in the switch and interfere with its operation. Fourthly, the switch should be lubricated as needed to ensure smooth operation. Lubrication can help reduce friction and wear on moving parts. Fifthly, the switch should be tested periodically to verify proper operation. Testing can help identify any potential problems and ensure that the switch is functioning correctly. In addition to the above, a properly sized and installed disconnect switch contributes significantly to the overall safety and reliability of the electrical system. It provides a means to safely isolate equipment for maintenance, preventing electrical hazards. It also protects against overloads and short circuits, minimizing the risk of damage to equipment and injury to personnel. Furthermore, it enhances the efficiency of the electrical system by ensuring proper voltage and current levels. A well-maintained disconnect switch reduces downtime and improves the overall performance of the electrical system. In summary, a 200 amp continuous rated primary disconnect switch is typically suitable for a 500 kVA transformer with a primary current of 125 amps. While a larger switch would offer an additional safety margin, it is not strictly necessary, and the 200 amp switch will adequately handle the load while adhering to safety and performance standards. Choosing the 200 amp switch can result in cost savings without compromising the functionality or safety of the electrical system. Remember to consult the National Electric Code and your local regulations for more specific requirements, and to always engage qualified electricians for installation and maintenance of electrical equipment.